All right, let's talk about auditing your PostgreSQL database. Today, we're going to break down the three main ways you can do it. Whether you're trying to meet compliance rules, beef up security, or just figure out what went wrong, picking the right tool for the job is absolutely crucial. So let's jump right in.
So let me start by asking you a question, a really important one. If some critical data in your database got changed right now, could you say for sure who did it, exactly what they did, and when they did it? Being able to answer that, the who, what, and when, that's the whole point of auditing. It's really your first and best line of defense.
So, what do we even mean by database auditing? Well, at its heart, it's just about keeping a systematic record of everything happening inside your database. And this isn't just about catching hackers, It's super important for things like financial regulations, getting ISO certified, or even just hunting down those really tricky bugs in your application. It's all about creating a record of your data's history that you can actually trust.
Okay, so our first method. This is the one that's already baked into every single PostgreSQL installation. It's easy, it's right there, but as you're about to see, it's kind of like using a hammer when you might need a scalpel.
All you have to do is flip one little switch in your configuration file. You just set log statement equals to all, and bam, you're logging every single query that hits your database. You don't have to install any extensions, there's no crazy setup, it's hands down the fastest way to get some basic eyes on what's going on.
But this is what you get, just a raw line of text. Now the good news is it shows you the exact command that was run. The bad news, it's just one line in a massive, ever-growing file of text. It doesn't really give you the full story, and trying to search through millions of these lines is, well, a total nightmare.
And that really gets to the heart of the problem here. This method is like a security camera that's just recording 24/7 everything without any kind of motion detection. You get this fire hose of information, and it's incredibly hard to search through. You can't filter anything. And a really key point, it shows you what was asked for, but not the rich context of what actually happened. So yeah, finding that one specific thing you're looking for is like finding a needle in a haystack.
Okay, let's move on to method number 2. If the default log is a blunt tool, then PG Audit is the precision instrument. It's the purpose-built solution, and it's pretty much the community standard for anyone doing serious auditing.
So PG Audit is an extension that basically plugs into PostgreSQL's existing logging system and just supercharges it. It's designed from the ground up to create the kind of detailed, structured, and filterable logs that regulators and auditors are going to ask for.
And wow, this slide really shows you the difference. On the left, you've got that raw log we saw before. On the right, that's PG Audit. Just look at that. It's beautiful. It's structured. It tells you the command class, DDL, for changing the database structure, the specific command, create table, the object type. It even gives you the full name of the table. Now, this is information you can actually work with. You can search it, filter it, and set up alerts on it.
PG Audit also fixes that fire hose problem we talked about. You can use the PG Audit log setting to tell it exactly what kinds of statements you care about. So maybe you want to log all schema changes and any data modifications, but you don't really care about all the simple select statements? No problem. That granular control is absolutely key to getting the signal you need with all the noise. But, and this is a big but, with great power comes great responsibility. If you just turn everything on, PG Audit can create a ton of logs. We're talking logs that can be several times larger than the actual data in your database. And that can chew through your disk space and put a real drag on performance, so you've got to be smart about how you configure it.
All right, on to our third and final method, rolling up your sleeves and building it yourself with custom triggers. This is definitely the most flexible and powerful option, but it's also by far the most complex.
The core idea here is actually pretty clever. For any table you want to audit, you create a second, parallel table, a shadow table if you will. Then you set up a trigger, which is just a special function that automatically runs every single time a row in your main table gets inserted, updated, or deleted, and it writes a detailed record of that change into your shadow table.
So how's it work in practice? Well, it's basically a 3-step dance. First, you create that shadow table to hold your logs. Second, you write a function that's smart enough to grab the row's data before the change, that's the old record, and the data after the change, that's the new record. And finally, you attach that function as a trigger, telling your main table, hey, run this code every time something changes.
So the huge pro here is control. I mean, you get total control. You can log the exact before and after values for every single column, and your audit trail is just sitting in another SQL table you can query.
But the cons are pretty serious. You have to set this up and manage it for every single table. That's a huge maintenance headache. And it can really slow things down, especially if you have a lot of writes happening.
Okay, so we've run through 3 very different approaches. The big question is, how do you actually choose which one is right for you? Let's try to put this into a simple framework.
Honestly, this table right here is probably your biggest takeaway. It really boils down to this. If you just need some quick and dirty visibility for debugging something, log statement equals all is your go-to. The setup is dead simple. If you have any real compliance or security needs and you need those structured logs, then PG Audit is the gold standard, no question. The setup is a little more involved, but it's worth it. And finally, for those 1 or 2 mission-critical tables where you absolutely must have a perfect row-by-row history, custom triggers give you that ultimate power, but just know it comes at a high price in complexity and potential performance hits.
Now, before we finish up, I have to point out one crucial thing, a massive limitation that, believe it or not, all 3 of these methods share. It's a bigger picture problem that people often miss.
And here it is, the shared database user problem. Just think about how your applications work. Most of them connect to the database with a single generic service account, right? Something like app_user. So your audit log might tell you that app_user deleted a record, but it has no way of telling you which one of your thousands of actual human users was logged into your web app and physically clicked that delete button.
And that leads to the final big picture question I want to leave you with. Your logs can be perfect. They can show you exactly what happened and precisely when it happened. But can they prove who is truly responsible? Answering that question means you have to start thinking beyond just the database itself and look at your entire system. Thanks so much for tuning in.